So in this video, what we'll be talking about is the conjugate of an imaginary number, what it means, and how multiplicating an imaginary number by its conjugate will affect its value and its rotation on the complex plane. So if we take the number z1 equals 1 plus I, and we have z1 bar, which this bar above it means that it's going to be the conjugate of z1. So the only difference between the conjugate and the regular expression is just that the sign is changed, and I will explain why that's important in a second. So if we multiply these two together, if we multiply the original one times its conjugate, we'll get 1 plus I times 1 minus I. And then from this, what we'll get when we factor this out, we'll get 1 plus negative I squared plus 0. And then from that, because I squared is negative 1, times another negative 1, which would make it 1. 1 plus 1 is 2. So what does this do in terms of rotation? And more importantly, what does this do in terms of shifting a number from being imaginary to being completely real? Because, right, this exists solely in the real numbers. This has no imaginary component. If you wanted to write this in terms of imaginary, this is 2 plus 0I. So if we look at this, what we get is we have 1 plus I in the first quadrant and 1 minus I in the fourth quadrant. And from that, when we multiply them together, we rotated the vector so that it's perfectly in between them. And not only that, but it only exists on the real number line. And what should be interesting is that this happens because a symmetry is created when a symmetry is created between the original imaginary number and its conjugate. If you look at this right here, that seems to be bisecting that angle between those two. I guess you could call them vectors, the angle that is made between the vector and the x-axis, and it is going through it perfectly. And that is because of the symmetry that happens here. And furthermore, what the most important thing you should know, and I'm sure you probably already know it, is that truly this is the reason why you can get solutions to polynomials that are actually real numbers. Because, right, if I square something by its conjugate, or, well, not if I square it, if I multiply something by its conjugate, I'm going to get a real number. So when you have imaginary roots to a polynomial, let's say, like something like a quadratic, what's happening is that when you multiply it through, is that the fact that the imaginary number squared is negative 1, which is a real number, allows you to get solutions to polynomials, because we say that I is equal to the square root of negative 1, which is the imaginary number. So overall, what you should get from this is that the conjugate of an imaginary number is represented by a bar over the original variable name, and that when you multiply them together, you're always going to get a real number. And from this, if you graph it, you'll see that not only will the two normal numbers be, the two normal numbers, there will be a symmetry between them, but you'll also see that the result will always be on the real plane, which is the x-axis in this case. So that's the end of explaining the conjugate. See you later.